Hi everyone, welcome to a very special video series that was done in collaboration with Luceda Photonics. A big thanks to them for providing their IPKISS license to make this collaboration possible. In this series, we'll showcase how their software, IPKISS, has some connections with Lumerical and can make the PIC design process a lot simpler and more streamlined. So to start off, I wanted to give a quick overview of Luceda Photonics. Aside from the IPKISS PIC design software that they offer, there are also PDKs that are available for different material platforms. This includes silicon, silicon nitride, indium phosphide, lithium niobate, aluminum oxide, and they also have some other kits for assembly and testing. They also provide services for PDK implementation and development, as well as design flow optimizations. They can provide specialized training as well for any of the above. So if you have any questions, please feel free to reach out to their support email regarding these matters. So an overview of IPKISS. So IPKISS is a Python-based software with many features that are useful for PIC design. It's very user-friendly in both the component and circuit design methods, and users can parameterize their design cells to instantly generate layout files, as well as full circuits. So the main categories that IPKISS can handle are component design, which it connects to Lumerical for, circuit design, which it can perform either in its own software, IPKISS Canvas, or as a exported S-parameter file for Lumerical interconnect. It also connects to another software that Luceda offers called Checkmate for design validation. And then finally, it can also do a lot of GDS generation or tape-out preparations. This includes connectivity tests and other really great features. So with the interoperability with Lumerical, there's a lot of functions that are built into IPKISS innately, and they're specifically for a few Lumerical tools, which are Lumerical Mode, EME, and FDTD. The great part of these functions is that you can perform many of the existing features in Lumerical already, such as setup scripts, LSF scripts, or single command calls. You can do exporting of S parameters, and you can also do custom macros. So you don't have to rewrite any kind of existing LSF files you may have. You can simply load them right into IPKISS. It also has a flexible framework. This allows you to create complex devices using existing P cells, and you can also generate full PIC circuits and also obtain the transmission responses all within your Python console. So there's no need to kind of dance between two softwares. In this video series, we'll give a quick overview here of the contents. We'll split into three parts, parts A and B and C. So in part A, we'll create a basic P cell device. It'll be using a Bragg grading straight waveguide as a demonstration. In part A, we'll showcase how to draw a geometry, define the device ports, view the results in the console. This includes the top-down view as well as the cross-sectional view. And then we'll showcase how to connect a Lumerical simulation to that P cell class. In part B, we'll extend that simple P cell class into an advanced device called the contradirectional coupler. The contradirectional coupler, as shown in the bottom right here, is essentially two Bragg grading waveguides that couple to each other. So we'll showcase how to reuse a P cell, redefine the ports, how to set up an advanced simulation from that, and then we'll run the simulation, export the S parameters, and then we'll showcase how to get the device transmission in the console. Finally, in part C, we'll bring everything together and we'll create a full circuit from the I/O all the way to the output. So this will be a grading coupler connected with waveguides to our contradirectional coupler, and then back out through a waveguide into another grading coupler. We'll showcase how to place the devices, connect the ports as necessary, perform a full circuit simulation, and then finally exporting to either a GDS file or into IPKISS Canvas. I also want to showcase the Luceda webpage here. So as mentioned before, with the PDKs we're going to be demonstrating in the examples in the later videos. They also have a lot more PDKs that are available. So with IPKISS comes some open PDKs you can use right off the bat without NDA. If you want some proprietary NDA PDKs, you can reach out to their support email. If you have any questions about installations or mentorship regarding IPKISS, you can also reach out to the support channel as well. And then the files that are going to be used in this video are also available either on our Simutrain platform or on our Simutech GitHub under Simutech Photonics. You can navigate to our repository called example lum IPKISS, and all the files should be here in this design folder. You can click this green button here that says code, and then there's a download zip button. So what users will want to do next is they'll want to create a project folder. In this case, I've created on the desktop here. It can be named anything, so I've named it example project. And then in your project folder, you'll want to place 3 things. The first one is you'll want to create an empty folder called designs. This is where you'll be placing your P-cell scripts. And then you'll also want to bring in 2 other folders. One's called additional utils, and the other one's called PDKs. So the additional utils and PDKs are going to be used by the IPKISS-sided library. And you should be able to find them by navigating to C drive, your user, and then there should be a folder called Luceda under your users folder. Navigate into Luceda Academy, and then inside that Academy folder, you should see additional utils, and you should see the PDKs folder. So with the PDKs folder, myself, specifically for this tutorial, I use the SciFab PDK, just as a quick example. But if you're working on different platforms, you can import different processes, PDK folders as well. And this is especially useful because it automatically handles certain layer definitions or waveguide definitions, so you don't have to redefine them all the time for your P-cells. You can just kind of quick swap them between different projects if you're working on different design platforms. So for example, in my example project here in PDKs, I have just a SciFab folder, which is copied over from the Luceda Academy folder that you saw. And then next, you also want to copy over this additional utils folder. Inside are some scripts used by IPKISS. So that's what it looks like over here on my project folder. And if everything was correctly imported, you can perform a test. So here I'll open up PyCharm, which is the suggested IDE when using IPKISS. Of course, you're free to use your own. And this will be assuming that you've already followed all of the installation guides from Luceda and have PyCharm properly set up. So specifically, you'll want to have the additional utils and the PDK folder properly imported. You can see here my folder icon is blue, indicating that I've set them as a source folder. Yeah, and that's really important to make sure it's already done. So next what you can do is create a blank Python file. In this case, I created a test.py. And then at the very top, you can copy these commands. The first one is from SciFab, which is my source folder. I want to import everything as something called PDK. And then from the IPKISS folder, I want to import everything as I3. And then if all goes well, you can click this Run Test button at the top or Shift F10. And you should be able to run the script without any errors. And this will be a good indicator that your IPKISS is properly installed and you're ready for the next few videos. And with that, I'll finish off this video here, and we'll see each other in the next video. Thanks.